Welcome, everyone. In this lesson, we're going to see how to use the first derivative to really help us find the intervals where our function is increasing and the intervals where it's decreasing, and then also help us to locate where we might have a minimum or a maximum for our function. So let's start with our first derivative and how it relates to the intervals of increase, decrease. And this is something we've talked about before, but what we saw is that if f prime is greater than 0, so if f prime is positive, then f is increasing on this interval. So if we have an interval and f prime is positive on that interval, well, then the original function is increasing. If we're looking at that interval and our derivative is negative on the entire interval, well, then that means our original function is decreasing. And so how we're going to actually figure out where our function, the intervals where our function is increasing or decreasing, is going to be, there's going to be a little work. We're going to do some steps. So let's just outline what those steps are going to be. So how to figure out the intervals of increase, decrease. So let's say we're given a function and we want to figure out what intervals is that function increasing, what intervals is that function decreasing. Well, our first step is going to be calculate the derivative. So we want to calculate f prime of x. All right, so that's going to be the first thing. We got to get our derivative. Then the second thing we're going to do is we're going to find what we're going to call the critical numbers of our function. So we're going to set f prime of x equal to 0, and then we're going to solve for x. So essentially what we're doing here, we're introducing a little bit of terminology. We're going to find the critical numbers of function f. So what do we mean by critical number? Well, a critical number is going to be an x value, so x equal to some number c, and it's called a critical number of function f provided our derivative is going to be equal to 0 there. And as we've seen in previous examples, when our derivative is equal to 0, this is when we have a horizontal tangent line, and this is precisely when our function can stop increasing and maybe switch over to decreasing. So these critical numbers, these are the possible places where the original function can switch from increasing to decreasing, or the opposite, from decreasing to increasing. So these places where the derivative is 0, those are precisely the places where our function can switch back and forth between increasing and decreasing. So we want to find those locations. Now, technically speaking, there is also a second way we can have a critical number, and that's if the derivative is undefined. Now, for our course, we're not going to see this example. So we're primarily going to be looking at where our derivative is 0. But technically speaking, there's two ways we could have a critical number. If our derivative is equal to 0, or if our derivative is undefined. But we're primarily going to be looking at this one. All right, so the critical numbers, these are the possible places where our function can change, can switch back and forth between increasing and decreasing. And so going back to our steps here for how to actually get the intervals of increase, decrease, we're going to calculate the first derivative. We're going to set the first derivative equal to 0 and solve for x, because Those are the places where it might actually change, where the increasing and decreasing behavior might change. And then once we have that, we're going to do a sign chart for f prime. So we're going to construct our sign chart for f prime. And as we're doing this, we can use test numbers, and we can plug them into f prime to help us determine the sign of f prime on each interval. So we're going to use test numbers to determine the sign of f prime. That's one way we're going to do it. Another way is we can just have it factored and kind of figure out that way as well. And we'll see that in some examples. So let's get into it. Let's try an example where we put this to practice. So let's look at example 1. We're going to find the intervals where this function f is increasing, and then we're going to find the intervals where f is decreasing. And our function here is f of x equal to 1/3 x cubed minus 2x squared plus 3x plus 1. All right, so what are the steps again? Well, the first step is we got to get our derivative. So let's calculate it. So step 1, let's figure out the derivative. And we're going to go through, differentiate each term. So we just differentiate term by term. Derivative of the first term is going to be x squared. Derivative of the second term is going to be 4x, and then we're subtracting. And then the last term is plus 3. So we're going to add 3 for our derivative. All right, so if we have our derivative, we can, the next step is to actually figure out where this derivative is 0. So we want to find the critical numbers. And the way we do this is we set f prime equal to 0. We set our derivative equal to 0, and then we solve for x. All right, so we have our derivative, but what's going to help is it's going to be helpful to kind of get this factored. So before we go any further, we have our derivative all calculated, but let's try to factor it. And when we do that, we get x minus 1 times x minus 3. Factors nicely in this case. And so to get the critical numbers, we're going to take our derivative and we're going to set it equal to 0. And so when we do that, let's use the factored version. So we're going to take this factored version, set that equal to 0. We get x minus 1 times x minus 3. We're going to set that equal to 0. And having it all nice and factored makes this really easy to solve for x. And we're going to get 2 values. So we can take the first factor, set that equal to 0. We can take the second factor, set that equal to 0. And when we do this, what do we get? We get x equal to 1 and x equal to 3. So those are our 2 critical numbers. So these are the 2 critical numbers of our function f. All right. So now we're going to use those for our sign chart. So that's the next part of this. We're going to do a sign chart for our first derivative. So we want to do a sign chart for f prime. So when we do this, we're going to draw our number line. And we can think of this as like being the x-axis. And so we're going to take these critical numbers that we found, and we're going to plot them on our number line. So x equals 1, x equals 3. And what they do in this case is they split up the x-axis into 3 separate intervals. So we're going to have the interval from minus infinity to 1. We're going to have the interval from 1 to 3. And then we're going to have the interval from 3 to infinity. And now we want to figure out what the sign of f prime is on each of these intervals. And so what can be helpful is if we use this factored version of our derivative to write down each of those individual factors. And then we'll put it all together to see what it tells us about f prime, and then ultimately what it tells us about function f. So let's start with the first factor here, x minus 1. And what we're going to do is we're going to figure out, is this factor positive or negative on each of these intervals? That's what we want to figure out. And so if we look at this first interval, we're looking at x values that are smaller than 1. So you can pick a test number, something inside this interval. So maybe like 0. So let's use a test number, we'll call it t equal to 0 here. 0 is in this interval. And you can plug it in to this factor. And when we do, we get 0 minus 1, which is negative 1. So this first term, this x minus 1 factor, is negative on this first interval. And we can play the same game for our other factor, x minus 3. X minus 3, if we take our test number, plug it in there, we get 0 minus 3, we get negative 3. So again, it's negative. And so what we have here is a negative term times a negative term. So when we multiply two negatives, they kind of cancel out, and they make our first derivative positive in this case. And so what that tells us then about the original function is, since f prime is positive, the original function must be increasing on that first interval. And now we just repeat. Now we go and do the same thing for each interval. So let's go to the next one, the interval from 1 to 3. Let's pick a test number. So we want something in between 1 and 3. So, keep it easy. Let's use 2. And I'm going to take this number 2, and I'm going to plug it into the first factor. So I get 2 minus 1, which is positive 1. So positive. Then I take that same test number, and I can plug it into the other factor of f prime. And when I do that, I get, what do I get? I get 2 minus 3. So I get negative 1. I'm negative. So this factor is negative on that middle interval. So what we have for this middle interval is we have a positive number times a negative number, and that gives us a negative. So f prime is going to be negative on that middle interval. And what that means for the original function is whenever f prime is negative, the original function is going to be decreasing. And so if we go to that last interval, we just kind of repeat the process again. So we want to pick a test number. So, 4 would work. It's something bigger than 3. And we want to take this test number and just plug it in again to each of these factors. So if we take 4, plug it in over here, we get 4 minus 1, which is positive 3. And then again, we take that same test number, go to the other factor, plug it in, we get 4 minus 3, which is positive 1. So what we end up with here is essentially a positive number times a positive number, which is positive. So f prime is going to be positive. And if our first derivative is positive, that means the original function is increasing. And so we were able to fill in the whole sign chart here. We were able to figure out, we had 3 intervals, and we were able to figure out the sign of f prime on each of those intervals, and that led us to actually know what our original function f is doing. And so when you kind of take this approach, you want to use all of the factors in f prime. So just a little caution there. You want to use all the factors as is. So you don't want to change anything because it can be sensitive to sign changes. So if we had for instance, if we had a number 2 in front here, well, we would want to include maybe 2 times x minus 1, or maybe we would make 2 a separate row. So the factors that we list here should include all of the factors that we have in f prime. All right, so we went through the process. We were given a function, and we were able to figure out first the derivative. Then we were able to find the critical numbers, and this is where a little bit of algebra came in. We had to first factor our derivative, set it equal to 0, and then solve for x. And then once we had that, we were able to fill in our sign chart for f prime. And usually for good measure, we want to just summarize our results. And so what we found is that f is increasing on the interval from -infinity to 1 and on the interval from 3 to infinity. And then we also found that f is decreasing on that middle interval from 1 to 3. So this is our answer here. Usually it's a good idea to try to summarize that up as well. All right, so what we're going to see next time is we're going to see, kind of using this same method of finding the intervals of increase, decrease, we're going to see how we can use these critical numbers then to locate where our function has a local max or a local min, the relative extreme points. So we'll see you then. Bye-bye.